In this video, we're explaining Retrieval-Augmented Generation, or RAG. This is the architecture that's fundamentally changing how AI interacts with private data.
So what is RAG really? At its heart, it's an architecture that connects a large language model to your own external private data. This allows the model to break free from its static, pre-trained knowledge and instead generate answers grounded in information that is current and, most importantly, verifiable.
To really appreciate why RAG is so significant, we first have to understand the core problem it's designed to solve. And that problem is all about the inherent limitations of standard large language models.
You see, a standard LLM's knowledge is basically a static snapshot. It's frozen in time, right at the moment its training ended. This creates a huge knowledge gap. The model doesn't know about current events or recent market data, but the big one is this. It has absolutely no access to your proprietary information, the contracts, the internal wikis, and all the support tickets that really define your business.
And that's exactly where RAG comes in. It's the solution. You can think of it as a dynamic bridge, connecting the LLM's powerful reasoning engine to live external data sources, right at the moment a query is made.
The logic is actually a pretty straightforward three-part process. First, it searches an external knowledge base for information that's relevant to the user's query. Second, it retrieves the most pertinent snippets of data. And third, and this is the key, it provides this retrieved context to the LLM and instructs it to generate an answer based only on that specific information.
All right, so let's get into the mechanics of how this actually works. The RAG process is divided into two distinct phases. There's a one-time data preparation phase, and then there's the real-time query phase. Phase 1 is all about preparation, and this is a one-time setup. Your knowledge base is ingested and broken down into manageable chunks. An embedding model then converts each of these chunks into a numerical representation, or a vector. These vectors are then indexed in a specialized vector database, which enables what's known as semantic search, that is, retrieving data based on its conceptual meaning, not just simple keyword matches.
Now, phase 2 happens in real time with every single query. The user's question is also converted into a vector, and the system performs a similarity search in the vector database to find the text chunks with the closest meaning. These relevant chunks are then automatically added to the prompt. And crucially, the LLM is instructed to formulate its answer based only on this freshly provided context.
When you put this two-phase process together, you end up with a really significant difference in capabilities between a standard LLM and one that's been enhanced with a RAG architecture. So, let's just boil it down. What are the tangible, practical advantages of implementing this kind of system? Well, the comparison is pretty stark. Without RAG, an LLM has static knowledge, no access to your internal data, and a significant risk of hallucination, of just making things up. With RAG, the model gets access to current, private information, and because the answers are grounded in specific documents it just retrieved, hallucinations are drastically reduced, and the sources can actually be cited, making the output verifiable. Okay, let's move on from the technical architecture and talk about where this technology is being applied to create real value today. The applications are already quite broad. RAG is powering sophisticated internal chatbots for HR, legal, and IT, providing instant answers straight from company policies. It's also being deployed for complex contract analysis, building enterprise knowledge bases, creating intelligent customer support systems, and even acting as a powerful research assistant for navigating vast document libraries. So the core distinction is this. The LLM provides the engine for language and logic, its ability to understand, summarize, and reason. RAG provides the fuel, that specific, current, and verifiable knowledge that makes the engine's output relevant and trustworthy. This leaves us with a final question. Every organization has valuable information that's just locked away in disconnected documents and databases. So the question now is, which of your knowledge silos is waiting to be unlocked and transformed into an interactive, intelligent asset?